Alright, ladies and gentlemen, this is Unit 4, Presentation 1. This unit's going to be broken down into 3 parts, and this part that we're going to go over is talking about our solar system. So for a lot of you guys, this might be the first time that you're ever going over astronomy or the study of space. And so we're going to break it down into this. The solar system we're going to do this week and next week, but we're going to talk more about the planets this week. Next week we'll talk more about like the smaller stuff like the moon, asteroids, and of that nature. And then the third part is we'll talk about stars and galaxies, so the things that are way, way beyond where we live. And we talk a little bit more about that and how small the Earth is compared to a lot of other things in space. But so in this unit, we're not going to do really a project, but I'm going to show you a lot of videos, little clips maybe, sometimes some full-length movies, just because it's better to show you all these things that are available. And you can go online too to watch a lot of cool like little videos that people have done about space and stuff. So at this point, you've watched 2 videos. You watched the first one, and then you watched the second one, the solar system song. Right, and then so let's get into the actual notes about the solar system. All right, and again, remember, we are always starting off by getting a highlighter and setting up our notes that way. Okay, so the first thing is the way our solar system was created is through gravity. So we talked about gravity, in Unit 2, and a little bit in Unit 3 and stuff like that, but the biggest force out in space is gravity, right? Because there's so much space in between. Like, how did everything get formed? How did planets get created? Well, it's through gravity. And actually, when gravity puts items together, it creates a ball. And that's the reason why when you look at pictures of planets and pictures of moons and stuff like that, it's mostly circular shape, because gravity, when things start coming towards one another and they start colliding, they actually make round objects. Right now, in our solar system, in most solar system, right, because that's the definition of solar system, it must include a few things, right? No matter what, it must include, and I'm going to check next to it, all right, it must have a star. I mean, that's a given. If it doesn't have a star, it can't be a solar system. All right, it's got to have a collection of planets. All right. And then after that, pretty much, it doesn't have to include, but you're going to get these other things. You're going to get like dwarf planets, and we'll talk a little bit more about that. Pluto was kind of the first kind of dwarf planet that really made a big name. That's the reason why we kind of talk about dwarf planets now. But moons, right? We look up at the sky every single night. There's a moon. Comets, asteroids, and meteors. These are what solar systems include. Now, you might have a question. Are we the only solar system out there? Absolutely not. All right. There's actually, they found in a telescope that there was a solar system that I think had 6 to 8 planets. I forgot how many that they found just recently and stuff. And that's not the only one either that they found. So there's billions of these guys, probably even trillions of solar systems out there. That have all these different things. So we're not the only ones with planets and a star. I mean, every single time you look up at the night sky, you see a bunch of stars. Now, it doesn't mean that every single one of those stars has a solar system. All right? There's some stars that just have nothing around it. It doesn't have planets around it. It just has space everywhere. We just so happen to have, next to our sun, these planets that just formed. It just kind of out of luck, I guess, that this kind of happened. But this is what the definition of a solar system is a collection of a star, planets, dwarf planets, satellites, comets, asteroids, and meteors. Okay, so everything in space does these 2 things. Right? It seems like the sun's not moving. It seems like we're not moving, but we are. And what we are doing, and what every object is doing, is what's called rotating, a rotation, and revolving, revolution. Right? And it's easy to mix up these words, but rotation means to spin around while standing still. The way I look at it is a top. right? When you spin a top, or even when you do like the little quarter, when you flick a quarter and it starts spinning, that's what rotation is. It means that if you just stand up and just twirl, right, just like a ballerina does, that's rotation, right? And one rotation equals 1 day. Okay, so if it spins around one time, it's 1 day. That's the reason why our day is 24 hours, because it takes the Earth 24 hours to spin one time around. Okay, so they didn't just make up the number 24 hours as a day. They did it because it takes the Earth 24 hours to spin one time. Okay, revolution, it means to circle around an object. Okay, it means to go around an object one time. So when you guys do the Cougar run, when you do one lap around the field, well, when you do one lap, there's something in this, you don't see it, but you're going around something in the middle. All right, it just so happens that when the Earth is going around, like if you look at the picture right here, we're going around the sun, right? So all the planets, not just the Earth, is doing this. They're revolving and rotating. And when we revolve, 1 year happens. So when you go around the sun one time, one revolution took place. So it did one lap around the sun. Okay? And that is 365 days for us. Okay? It's actually 365.25 days, and we'll talk. That's the reason why we have leap year and stuff, but I'm not going to get into the specifics. If you want to ask me about it, you can. But they didn't just arbitrarily come up with 365 days equals a year, right? It's not just some brain trust that came up with that number. Well, what they found during doing math was they found that it took 365 days for the Earth to go around the sun one time, and that's how we got our calendar year. Okay, so these numbers right here that you see, it's not random. There's a reason why we have that. So that's how we get our years. That's how we get our days. Okay, so through rotation and revolution. And like I said again, every object does it. When you look up at the sky, the moon does it. Okay, the sun does it. Yes, the sun is actually revolving, and it's actually rotating, right? Rotating, and it's also revolving around something. Right? We just don't know what that is. It's revolving constantly. All right, so let's talk about now the specifics of all the objects in our solar system. So the first thing you have to start with, because this is the giver of life. Without it, we've got nothing, which is our star. We call it the sun. Okay? Now it's always at the center of the solar system. It's the most important. Okay, I can't even stress enough to you the most important object in our thing. Because if the sun goes, we go. All right, and yes, our sun is dying. Now, when I say dying, it's not going to die in 2 weeks. It's going to die in 500 million years. All right, but it's millions and millions of years before it goes away. So it's not like during our lifetime something's going to happen to our sun. Right now, our sun is a medium-sized star. Okay, now when I say that, you look out and you go, that's a big star. All right. However, in comparing it to all the other stars that you see in the sky, it's actually one of the average-sized stars. It's not huge. It's not that big. I know when you look up at the sky, you just see these little tiny lights outside, but those things are really far away. And all those that you pretty much see in the sky are a lot bigger than our sun. Okay, so it's a medium-sized star. And we'll talk a little bit more in a couple weeks about what the classification is, but it goes medium, then it goes huge, and then it goes giant star. All right? And the sun gives us two things. It gives us heat, and it gives us light. Right? Like I said again, it's the giver of life. Because without heat and light, you can't live. Okay? So now, what is the sun also? It's also called the producer of light. Okay? And it's the only producers of light. And I want to make sure that people understand that concept. Okay? All other objects in space, okay, are reflectors of light. What I mean by this is when you look at things out in space, when you see like the moon, the moon is not the one producing light. When we see light from the moon, we actually see what's called reflected light. You see it because the light from the sun, like if you look at this drawing right here, the light hits the moon, and then that light, same light, bounces light back to the earth. And that's the reason why we get to see the moon. Okay, it's not the actual moon that, like a light bulb turns on the moon. No. Okay, we're seeing actually light from the sun, but it's reflecting. It's like a mirror that we're seeing. All right. So, for example, let's say that you turn off all the lights in your room right before you go to bed. What happens? It's really, really dark in your room. You can't see anything, right? But then what do when you turn on the light switch? You can see everything. Well, does that mean that everything all of a sudden in your room light up? Like your desk. Does your desk produce its own light that you can all of a sudden see it? No, what you're seeing is because you turn on the light switch, you can actually see your light because now the table is reflecting light back into your eyes. So like the only thing that produces light in space are stars. Everything else in space is a reflector of light. Our Earth is a reflector of light. So I have this two images that I want to show you guys. So here is a picture of our Earth from space. Okay, it's lit up and stuff like that. Now, does that what our actually Earth look like? No, our Earth actually looks like this, right? When it's in darkness, right? Because our Earth does not produce light. Now, if you see all these tiny little lights, this is artificial light, the light that we create. So if you look at these are two pretty close images, right? This is actually United States, and you can see that there's a lot of lights on the East Coast over here. All right, this is artificial light from cities and all that kind of stuff. But really, if you look over the ocean, stuff like that, there's no lights. The only reason why we get to see light like this in this picture is because the sun is reflecting off of that. Okay, so the Earth really looks more like this. It's just when the sun's hitting it, we get to see that reflection. Okay. So again, it's a really important idea that you understand that when you look up at the moon, you're not actually seeing the light coming from the moon. You're actually seeing light that's coming from the sun that's reflecting off of there. Okay. Oops, let's skip that. All right, so let's talk about the planets now. Planets, just like every other thing. So since the sun is in the center, planets revolve around the sun. Everything in our solar system revolves around the sun. So everything goes around it. Okay. Now, planets can divide up into two groups. Inner planets and outer planets. Next week we'll talk about actually specifically what object breaks up the inner and outer planets. But Mercury, Venus, Earth, and Mars are in the inner planets. Those are the ones that are closest to the sun. That's just why they're called the inner planets. Jupiter, Saturn, Uranus, and Neptune. Yes, it's Uranus, not Uranus, like all of you guys call it. And you're probably giggling right now since I said Uranus, but it's not. It's Uranus. Okay, let's everybody say it together. Uranus. Okay, it's almost like you're saying urine first. So it's Uranus. So I don't even know which one's worse, Uranus or Uranus. Take your pick. But anyway, it's called Jupiter, Saturn, Uranus, and Neptune are outer planets because they're far away from the sun. Okay, now there's only 8 planets. If you guys really thought there was 9, because maybe when you were in elementary school you might have learned it as 9. Pluto is no longer a planet. It's a dwarf planet. We'll talk more about that next week. But anyway, if you want, so one of the things that you can do is use an acronym, and I use this. My very excellent mother just served us nachos, and this might be a little bit different than what you learned it. So the way you use an acronym is the first letter goes with the name of that planet. So if you want to remember these from closest to the sun away, so it goes Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. That's the order of the planets starting from closest to the sun to the farthest. So if you notice, my for my very, right, and M go together. And then you go V for very and Venus. So if you kind of see it, excellent, Earth. So if you remember this phrase, my very excellent mother So M for Mars, mother, MM, just, right? J served us nachos. Okay? So you can kind of look at it that way and remember it. So if you just remember, my very excellent mother just served us nachos. So if you're having a hard time remembering the planets in order, that's a great way for you to remember the planets in order from the from the sun. But anyway, what you'll notice about planets, they are all round. All right, why are they all round? Again, because gravity. When gravity formed these planets, when all these like dirt and dust and all that stuff combined through gravity, because they attracted to each other, it creates these balls. And so that's just why in all the pictures that you see, they're always round. Okay, but they all revolve around the sun. Okay, so that's a little bit about planets. All right, now planets can also be broken up into another group called terrestrial versus gas planets. Okay, so terrestrial planets have a rocky surface. All right, and gas planets, by the way they sound, they're made up of pretty much all gas. They have an iron core in the middle, but when you look at a picture of, like, say, Jupiter, so this is Jupiter right here, that's actually all gas. It's like if you were to, and I'm not saying that you can, if you were to try and touch it, you would touch just like you're touching through air right now. If you wave your hand, that's what Jupiter would feel like. Now it just has a color to it, because just like our Earth has color to it, you know, doesn't mean that that's the Earth is like that, but it's basically full-on gas. All right, now our planet is a terrestrial planet because you can actually walk on it. We have rocks, so anything that's rocky. So what you'll also notice is that the terrestrial planets are all inner planets. So Mercury, Venus, Earth, Mars, they all have rocky surface, and all the gas planets are outer planets. It just worked out that way. And there's actually a specific reason why that is. And we'll talk a little bit more about that after your first activity that you guys are going to do. Hopefully some of you guys can figure out why the inner planets are terrestrial and why the outer planets are gas. It's a little, if you think about it hard enough, you can figure it out. Okay. And the last thing we're going to talk about is the measurements in solar system. So far, when we've talked about like measuring stuff in our class, we've talked about measuring stuff in meters or centimeters, right? Or if you even want to go kilometers for even farther distance. I'm going to tell you right now, measuring our space is so big. And we're just talking about our solar system, which is just a tiny little part of actual what space is. Okay? Because our solar system is so big, we don't use miles or kilometers to measure distance. Okay? In the solar system, we use what's called astronomical units, or AU. And the way we figured this out is we just basically created a brand new, just a brand new measuring distance. And what we just said, look, why don't we just call the distance from the Earth, okay, this one right here, to the Sun, 1 AU. Just call it a 1 AU. So a bunch of brainiacs did this. So they decided to say 92,960,000 miles is equal to 1. All right? It was just easier to write, easier to say than saying 92,960,000 miles. It's just 1 AU away. They just made it up. Okay, it's just like me saying, hey, the distance from here, from where Mr. Ozeni stands to the board is 1 Ozeni. All right? I can make that up, and if enough people wanted to use it, they can say, hey, I'm 3 Ozenis away. Instead of saying I'm 18, or I'm 8 meters away, they're saying I'm an Ozeni away. So it's just, that's basically what they did. But they just took the distance from the Earth to the Sun and called that 1. It was a smaller number. They can easily use that. So when we're talking about distances in our solar system, we're going to be using astronomical units. We're not going to use kilometers. We're not going to use miles or meters. Just too big, too large, right? Just to think about that number is ridiculous. All right, so that's how we measure things in the solar system, astronomical units. All right, And that is our notes for this week. So do your summary here, and that is it.